Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. We'll present about Fourier series signal. So here we will be four presenter, which is the first one is Muhammad Syami Hilmi bin Zaharuddin, Muhammad Aiman Arif bin Zakaria, Nur Aiman Hakim bin Sharif, and the last one is Haris bin Hussein. Okay, so for the introduction, an infinite sum of sines and cosine is used to represent the expansion of a periodic function into a Fourier series. The orthogonality relationships between the sine and cosine functions are used in the Fourier series. Since a Fourier series is the sum of many sine and cosine, it has various use in mathematical analysis. As a result, it is simple to distinguish and integrate, which makes it useful for analyzing functions like saw wave, which are periodic signals used in experiments. Additionally, it offers an analytical strategy for resolving the discontinuity issue. This helps in the solution of challenging differential equations in calculus.
So for the task one, we need to make a manual calculation first. For the Fourier series expansion, we need to calculate the value of a naught, and this is the equation. For an, this is the equation, and for the bn, this is the equation. And then we transfer the Fourier series expansion equation to the MATLAB. And this is the program of the MATLAB. So we need to plot the signal in time domain for 5 harmonics, 10 harmonics, and then 20 harmonics. And when we run the program, we got the answer like this. This is for 5 harmonic, 10 harmonic, and 20 harmonic. Then for the frequency domain, this is the program, and we run. So this is the frequency domain for the task one.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Muhammad, and today we'll be explaining for the second task. Later the board got proving the HF. So this is the manifestation. The frequency for our group is Hz. HF is 1 over 1 plus J2 pi RC, and the cutoff given as 1 over 2 pi RC. So we need to go for the manifestation. Start with omega equals to pi f. Then for the test is x j omega over x j omega. Then based from the circuit given is x j omega over x j omega, so we can convert it ZC over ZC plus ZE. Then we go back to h j omega. So it is equal to 1 over j omega c over 1 over j omega plus r. Then we cancel out and we get 1 j omega c minus j omega c over 1 plus r j omega c. So we can cancel the j omega c and we get h j omega as 1 over 1 plus j r w c. Then we sub the for 1 hf equals to 1 over 1 plus j2 pi frc. Then pi is at the given frequency, which is 50 Hz. So to find the frequency cutoff, it is actually multiplied by 4. So 30 multiplied by 4 is 120 kHz. 1 over 2 pi RC is close to 120 kHz. Frequency cutoff. And put R as 1 kilo, assuming it as 1 kilo. Then we get C is 1.6 nanofarad. HS is 1 over 1 plus RC. So HF is 1 over 1 plus J2 pi RC. F is 1 over 1 plus J2 pi F RC. So omega is 2 pi over T. T equals to 1 over F and pi over 1 over F. Then we can substitute the omega. Omega equals to 2 pi F. Sub into the equation. Yeah. Sub to the equation of 1 over 1 plus SRC. Then we get 1 over 1 plus S, the value of RC. 1 times 1.2869 per Hello, Assalamualaikum. Now for the simulation of the task 2. So we have the frequency 30 kHz, cut off of 120 kHz. So calculate using MATLAB. So we have C is 1.32 same with the manual calculation. Put in this coding to find the code, find the code to the diagram. Thank you.
Okay, thank you to all my friends. So I am Muhammad Azmi bin Muhammad Fauzi. My metric number is CE200147 from group 4. We'll explain for task 3, which is we analyze for the task 2 frequency domain and time domain. Here is the solution for the time domain and frequency domain. Which is here is the MATLAB coding for the time domain. After I input the MATLAB coding in time domain, we get the output result is here. This is the output result for time domain, and then we need to find and analyze the frequency domain. So here we get the input for frequency domain, and here is the output result for frequency domain. Here is what we get in frequency domain.